All right, let's go ahead and go over the answers for the warm-up. Who can tell me what they got for problem number 1 when we have the square root of 200, x to the 10th, y to the 7th, z to the 9th? What did you get in simplest form? Mateo? You forgot your z. Let me call on somebody else, okay? Josh?
10 square root, wait, no, 10 x to the 5th, y to the 3rd, z to the 4th, square root of 2yz.
Very good. Okay, so we get 10x to the 5th, y to the 3rd, z to the 4th, 2yz. So when we break this apart, again, you're going to go over and find out what's the largest perfect square that can divide into 200, which happens to be 100. So you're going to break this up as square root of 100 and square root of 2, because 100 times 2 is going to give you 200, and 100 is the largest perfect square that can divide into it. When we simplify, the square root of 100 is going to be 10. Square root of 2, you cannot simplify that. So it stays as square root of 2. The square root of x to the 10th, that is already a perfect square. So you're going to simplify it by dividing the exponent in half, so it's x to the 5th. Y to the 7th needs to be broken apart because it's an odd. You're going to break it apart, take 1 away, so it becomes y to the 6th, and then attach a square root of y to the end. Now that it's a perfect square for y to the 6th, you can go ahead and break it apart by dividing it in half. So that becomes y to the 3rd, and then you still have square root of y. Same thing for z to the 9th. You're going to break z to the 9th up by taking one of the exponents away, so it becomes z to the 8th, and then having a separate z. Square root of z to the 8th is going to simplify as z to the 4th because you divide it in half. And then you have square root of z. And then lastly, you want to go ahead and combine everything together. So anything that is outside of a square root sign will go outside and in the front. So we have 10 x to the 5th, y to the 3rd, and z to the 4th. Anything inside, so we've got square root of 2, y, and z. So there's our final answer. 10, x to the 5th, y to the 3rd, z to the 4th, square root of 2yz. Okay? It's a long one. What about number 2? We've got square root of 14xy. Lena? Cannot be simplified, can't be factored. That is as simplified as it possibly can be. There's no perfect square that's going to go into 14. X and y are already as an exponent of 1, so it can't be simplified any further. So this one cannot be factored. So that would mean square root of 14xy is as simplified as it's going to get. Okay? What about for problem 3? Elijah? 7xy to the 4th. All of these are perfect squares, every single one of them. Square root of 49 is just 7. The square root of x to the 2nd is just x. The square root of y to the 8th is y to the 4th. So that is as simplified as it's going to get. 7xy to the 4th. No square roots left. And then what about for problem 4? How simplified can that get, Grant? 10 square root of 6x. Very good. Square root of 600 can be broken apart as the square root of 100 and then the square root of 6. Square root of 100 is just going to give you 10, so you have 10 square root of 6. And then square root of x cannot be simplified any further, so it's just going to stay square root of x. It doesn't have any evened exponent that can be removed from it. So then when you pile it all together, it's just 10 square root of 6x, and that's it. Any questions? Annalise?
Number 3, why didn't you put it in the square root?
Because once you've actually taken the square root, that radical sign is gone. So there isn't anything that has to remain under the radical sign because all of these are perfect squares. When they're all perfect squares, there is no radical. Okay? Any other questions? All right, so let's go ahead and add quotients into the mix. Quotients today. Colin, you don't need to focus on your shoes anymore. You've tied them enough. All right, quotients with radicals. Basically, we're just going to dive right on in. If I give you a square root of 5/9, square root of 5/9, just the same as we could break a number apart into multiplication, you can break this apart into division components. So when we're looking at this, I can actually say, instead of saying one large radical sign with 5/9 underneath it, I can break it apart into a numerator, a square root of 5, over a denominator, square root of 9. Now, the nice thing here is that the square root of 9 happens to be a perfect square. What is the square root of 9? 3. So I can go ahead and put 3 as my denominator. Can I break apart square root of 5? No. Square root of 5 is not perfect, and it cannot be simplified. Or factored. It can't be factored. So that's just going to say square root of 5. So there's our final answer, square root of 5 over 3. Here, I'll write it further off to the side. Yeah. Huh? I am recording, yes. So if you guys need these notes later, if you need to rewatch or anything, you can look online. Now, it's not always going to be so perfect where your denominator is going to have a perfect square. Sometimes it won't. But what you want to do is you want to look and see, is there any way that you can simplify your fractions ahead of time before you start trying to simplify. So if I were to give you a problem like the following, if I have x to the 5th over 81x, x to the 5th over 81x, and it's also inside the square root, we know that when we break this down, x to the 5th is going to actually look like what? X to the 4th and then x. Or if I were to break it all out, if I just wanted it in standard form, long written form, instead of an exponent, I know that when I write it out, it's a bunch of x's, right? How many x's? 5 of them. So x times x times x times x times x. And then when I look at the numerator, I'm going to leave 81 as it is, but I also have it as a times x. And when we did our unit last semester talking about division, where you had the same base, what did you do with your exponents? Division, and it's the same base. Colin? You can cross out anything in common, right? So if I had like x to the 20th divided by x to the 2nd, how would we work that out? Do I need to draw a whole bunch of x's? No. What operation helped us simplify when it's division with the same base? Subtraction. So we would subtract the exponents. That's just what we're doing here again. If we have x to the 5th and we have x to the 1st, we can technically subtract those. One of these x's would wind up getting crossed off, wouldn't it? We'll use blue. So I would cross off that x and cross off 1 with it. So then what am I left with? I'm left with the square root of x to the 4th over the square root of 81. Are both of these perfect squares?
Yes.
Yeah, they're both perfect. What's the square root of x to the 4th? X to the 2nd. What's the square root of 81? 9. So you'd get x to the 2nd over 9. Let's take a look here. We've got the square root of 12 over 27. Are any of those perfect? No. Can we simplify? Yeah. So let's go ahead and simplify first. What are they both divisible by? 3, right? They both can be divided by 3. So if I divide them both by 3, what is 12 divided by 3? 4, right? So that's going to leave me with the square root of 4. What is 27 divided by 3? 9. So that leaves me the square root of 9. Are either of these perfect? Yeah, both of them are. What's the square root of 4? 2. What's the square root of 9? 3. So the square root of 12/7 is just 2/3. In these situations, I'm going to go ahead and say, no, don't worry about it. I'm more focused on you being able to factor correctly and eventually rationalize correctly. Because soon we're going to get into problems where you're left with a radical in the denominator and you're going to have to rationalize that denominator. Okay? So I want you guys to go ahead and try these 2 examples on your own. All right, who can tell me what they got for problem 4? Jordan? You have to simplify. Right, don't forget, because all of that's inside of a square root, so you've got to take this, you've got to simplify it all the way. Colin? M over 3. So you simplified inside the radical, Jordan, but you didn't actually do the, like, take the actual square root. So here, we know m to the third over m. We can go ahead and simplify that this m is going to go ahead and disappear, and that 3 is going to become a 2. Right? We can go ahead and subtract the m away. So now we're left with the square root of m to the second over the square root of 9. And square root of m to the second is going to become m. Square root of 9 is going to become 3, so we get m over 3 as our final answer. What about problem number 5? Grant?
Square root of x over 9.
Not over 9. Lena? Not x over 6. Heaven? No. Anybody else want to try one more time? Arham? No. So let's go ahead and break this down. Let's take a look at this. First thing we want to do is we want to try and simplify anything that we can. So we know that here the x to the second and the x, obviously that can be simplified, right? We can remove this x, and we're going to cross this off, and what exponent is that going to become? A 1. I'm going to zoom in here so you can see it easier. That's going to become an exponent of a 1. Okay? Now, I'm going to leave 4 and 36 alone. Even though they can be simplified, they can. But I'm going to leave them alone because of the fact that they're both what? Perfect squares. And there's a reason why I want to leave it alone, especially if the perfect square happens to be in the denominator. And we're going to get to that in my next example I'm going to show you. If your perfect square, if your denominator is already a perfect square, leave it alone. You can simplify later if need be, but leave it alone. You want perfect squares in your denominator. It makes the problem easier, because if your denominator is not a perfect square, you have to rationalize it, which means you're going to have to do some extra steps of multiplying by the exact same radical to get rid of the radicand. Okay? So you want to make sure that if it's already a perfect square in your denominator, you leave it. If it's not a perfect square in the denominator, you try to see if you can simplify it into a perfect square. Okay? So we're going to break this apart. I know I've got the square root of 4. I also now have a square root of x to the first. And then in my denominator, I'm left with just the square root of 36. So what is the square root of 4? 2. Can I simplify the square root of x? No, so it's going to stay square root of x. What is the square root of 36? 6. Now I check to see, hey, both of these are outside of square roots. Can I simplify those? Yes. What are they both divisible by? 2. They're both divisible by 2. So when I simplify this as my final answer, this is going to be, if 2 divided by 2 is what? 1. Do I have to write the 1? No. So this is just going to be a square root of x. And what is 6 divided by 2? 3. So it's square root of x over 3, and that's your final answer. It's very important that you understand that that square root is only in the numerator and not the denominator. Okay, so let's take a look at an example of when I told you, hey, it's really important that if you've got a perfect square in your denominator, leave it. Let me show you why. So if I were to give you a problem like the square root of 80 over 25. There's two different ways that I could solve this. Okay, the first way is the way that I told you, where you don't simplify the perfect square. In the denominator. You leave it alone. You just break it apart where it's a square root of 80 over a square root of 25. So square root of 80 is not a perfect square, but I can break it up. I can break it up into multiplication problem. Who can tell me the largest perfect square that can go into 80? Heaven? Not 9. Grant? 4 is not the largest. It is a perfect square that can go into it, but not the largest. Justin? 16. Okay, we can break this up as a square root of 16 and a square root of 5. 16 times 5 will give us 80. 16 is the largest perfect square that can go into it. Square root of 25 is already perfect, so we're going to leave it as square root of 25. And then all we're going to do is we are going to simplify those perfect squares. So we can simplify the square root of 16 and we can simplify the square root of 25. What is the square root of 16? 4. We don't know the square root of 5. We leave it as it is because it is an irrational number. And then what is the square root of 25? 5. Can we simplify 4 and 5? No, 4 and 5 is as simplified as it's going to get, so we leave it. This is our final answer. 4 square roots of 5 over 5. The second way to solve it is simplifying first. Simplifying first. So if we take the square root of 80 over 25 and I simplify it first, I know that they're both divisible by what? 5, right? They are both divisible by 5, which is going to give me the square root of 16 over the square root of 5. And then I would go ahead and I would simplify. I know that, hey, square root of 16 can be simplified. It can become a 4. But then I'm left of 4 square root of 5. And that's a problem. The reason it's a problem is because you are not allowed to have a radical in your denominator. It's not allowed. So go ahead and make a little note right there. You're not allowed to have a radical sign, a square root, as your denominator. So when something like that happens, you have to do what's called rationalizing your denominator. You have to rationalize the denominator. And the way we rationalize our denominator, so if we've got 4 over the square root of 5, to rationalize it, you're going to multiply both the numerator and the denominator by the denominator. So to rationalize it, I'm going to multiply both the numerator and the denominator by the square root of 5. So 4 times the square root of 5 is just going to be 4 square root of 5. Square root of 5 times square root of 5 is going to be 5. The square root is now gone. Because what's 5 times 5? 25. And what's the square root of it? 5. So when you rationalize a denominator by multiplying a square root by itself, it gets rid of the radical, and you're left with just what's called the radicand, what's inside. Okay? And that's your final answer. Same thing, right? Took a little bit longer. And there are going to be times when you have to do this. You're going to have to know how to rationalize denominators no matter what. But if your denominator is already a perfect square, save yourself the hassle of having to rationalize. So let me go ahead and give you guys a couple of problems to try on your own. Just 2 to try on your own right now. What was that? Was that number 6? All right. All right, who can tell me what they got for problem number 7?
What?
Who can tell me what they got for number 7? Heaven? 2 square root of 5 over 7 is correct. So the thing that you should do is you should break it apart. We've got the square root of 20 as our numerator, the square root of 49 as the denominator. Square root of 49 is already a perfect square, so we're going to leave it as it is. We're going to break up the square root of 20 into the square root of 4 and the square root of 5 over the square root of 49. So now we've got square root of 4, which is a perfect square, and square root of 49, which is a perfect square. The square root of 4 is going to give us 2. We still have it as a square root of 5. And then in the denominator, the square root of 49 is 7. 2 over 7 cannot be simplified, so this is our final answer, 2 square root of 5 over 7. For problem 8, who can tell me what they got? Grant?
2 b to the second and 2b to the second and the square root of 5 over 5.
Yes, correct. 2b to the second and square root of 5 over 5. All right, so when we take a look at it, the first thing that I note, 25 is a perfect square, but is b to the third? No. However, I can get rid of b to the third because I've got plenty of b values on the top, right? I've got b to the 7th over b to the 3rd. That I do want to focus on simplifying it. So when we work here, I know I'm going to get rid of all of the b's on the bottom, and b to the 7th is now going to become b to the what? B to the 4th. So that becomes b to the 4th. Okay, so now when we break this apart, we're going to have the square root of 20, square root of b to the 4th over the square root of 25. Square root of 20 can be broken apart. What are the perfect squares for square root of 20? 4 and then 5, right? So we have square root of 4, square root of 5, square root of b to the 4th over square root of 25. All my perfect squares, 4, b to the 4th, and 25 are my perfect squares. Square root of 4 is 2. Square root of b to the 4th is b to the 2nd. And then square root of 25 is 5. The only thing that I'm left that's not a perfect square is that square root of 5 on the top. Any questions?
So for number 7, if the bottom denominator is a perfect square, you just take the 2
If it's a perfect square, you go ahead and do the square root of it. You don't want to simplify it ahead of time.
So once on top, you just find out the 2 square roots that fall between and simplify from there.
Not the 2 square roots that it falls between. You want to break it apart into a perfect square and a non-perfect square that are factors of it. Right? 4 times 5. 4 times 5 is 20. Right? 4 times 5 is 20. So we're breaking it apart. We're finding the largest perfect square that is a factor of that 20. So if this had been, 32, then we would have broken it up as 16 and 2. Okay? All right. Let's see here. Let's take a look at this problem. Do I have any perfect squares in my denominator?
Yes.
Yes. What is it?
125 is 15. And the right to the check.
125 is not a perfect square. That's a perfect cube, but it's not a perfect square. But there is a perfect square for y to the 10th. Y to the 10th happens to be the only perfect square in the whole bunch. So since my numbers are not a perfect square, what I'm going to do is I'm going to go ahead and pull that perfect square apart. I'm going to write it all as, hey, I've got the square root of 65, I've got a square root of x to the 5th, and I've got a square root of 125. I'm going to go ahead and pull y to the 10th out as its own because I know that that's a perfect square. So what I want to do is I want to focus on simplifying my numbers to see, can I make a perfect square out of this? So what are my numbers both divisible by? Because I'm going to have to simplify those anyway. They're both divisible by 5, right? So if I divide both of these by 5, what is 65 divided by 5? 13. Okay, so I have square root of 13. And I still have square root of x to the 5th. What is 125 divided by 5? Not 55. 25. Is 25 a perfect square? Yes. So I've got a perfect square here for 25. And I now have a perfect square here. Y to the 10th is a perfect square. My whole denominator is a perfect square at this point. So now let's focus on breaking things up. Can I simplify square root of 13? Can I factor it out? No. Square root of 13 is as simplified as that's going to get. So I'm going to leave it square root of 13. What about square root of x to the 5th? Can I break that apart? What perfect square is that? X to the 4th is going to be the perfect square I can pull out and still be left with an x, right? Square root of x. And then for my denominator here, I've got square root of 25 and the square root of y to the 10th. Okay, so here's all my perfect squares. So what's the square root of x to the 4th? X to the 2nd. Don't say 2. X to the 2nd. Square root of 13 and square root of x are not perfect, so they are going to stay inside of the square root. They're going to remain radicals. What about my denominator? What is my denominator now going to become? 5y to the 5th. And that's my final answer. Huh?
Can I come for a help session?
I won't be here Wednesday. Remember?
Thursday?
Huh?
I got Tuesday?
I will make my help session Thursday.
Can I do it Tuesday before the quiz?
Tuesday,
No,
I think we can do it tomorrow. Tomorrow morning I'll have a help session.
I have yearbook tomorrow.
I do have a help session for tomorrow morning. I'll be here. And so if you're wanting to come, though, you're going to have to get your agenda signed. Okay? And then tomorrow we don't have class time because you guys have a health survey.
Do you have a what?
A health survey, and they're going to be doing it in math class. So,
A health? Like we're gonna work out.
no, health survey, student health survey.
Yeah, like what do you
Not what you eat.
like health? What do you mean by health?
Here.
It's like those things where it's like, I feel like I need to hurt.
Quiet. Shh. Quiet, guys. All right, what I'm going to go ahead and do is I'm going to give you guys a few practice problems right now to write down for your assignment. And then the last 10 minutes of class is you are supposed to be putting your butterflies up today.
Oh yeah, I forgot we were getting one too.
Hold on, hold on. Let me write the problems down. Gonna give you guys a few minutes to work on it so that you have some time in class to work on it. And then the last 10 or 15 minutes before Pride is over is when you're supposed to be putting your butterflies up. Okay? So, shh. Wednesday I'm at a math vertical meet. Means that elementary, middle school, and high school math teachers are meeting together so that we can discuss things to do across the board to align everything vertically. Shh. Whoever's phone is still on going off, please turn it off. Shh.
Can I still text you for help?
Absolutely. Until 8:45 every day. In case you need to see that a little easier, that's an x to the 10th right there. All right, so there's your assignment. You may work on it now. Go ahead.
To become